Take a deep breath. In a normal room, the air you just pulled into your lungs is packed with millions of microscopic dust particles, fibers, and bacteria. It's perfectly normal and usually harmless. But inside an operating theater or a pharmaceutical lab, that everyday air is lethal. In those spaces, a single speck of dust can cause a fatal infection during surgery or ruin millions of dollars worth of medicine on a production line. You cannot rely on standard bricks and cement to solve this problem. Instead, hospitals and labs use modular cleanrooms. These are precision-engineered environments built in a factory and assembled on-site to create an airtight, sterile zone. A cleanroom relies on a logic of layered defense. It starts with the physical outer shell to seal the perimeter and extends down to filtering the exact air molecules allowed inside. A modern cleanroom is a highly calibrated machine, specifically designed to isolate patients and sensitive products from the contaminated outside world. Look closely at these walls. Instead of drywall, cleanrooms use specialized sandwich panels for seamless, flat surfaces with no gaps. Even the entryways are modified. These blue flush doors sit recessed completely flat against the wall, eliminating protruding frames where bacteria could hide. The final piece of this outer shell is the ceiling, but it serves a dual purpose. This is a walk-on ceiling. It is structurally reinforced so technicians can actually walk directly above the room to perform maintenance on lighting or air ducts. They can fix equipment from the outside without stepping foot inside and contaminating the sterile space below. This smooth, flush shell creates a sealed vault. But for anyone to actually work inside, that vault requires a highly specialized respiratory system to supply it with pure air. That breathing process starts here with the Air Handling Unit, or AHU. Operating as the massive metal lungs of the building, it pulls in raw outside air, cools it, and prepares it for extreme purification. The prepared air then travels through fabricated ducting. These custom-built, galvanized metal tunnels are tightly sealed at every flange to prevent any pressure loss as they route the air toward the cleanroom. At the end of those ducts, the air hits the ultimate trap, the 0.3-micron HEPA filter. To understand how small that is, look at a human hair, which is about 70 to 100 microns wide. Shrunk down to 0.3 microns, you hit what physicists call the most penetrating particle size. Because of how air moves, 0.3 microns is the hardest specific size of dust or bacteria to catch. If the microfiberglass web is dense enough to trap that, it automatically captures everything larger and everything smaller, including viruses. The heavily filtered air is pushed into the room through a ceiling-suspended laminar airflow unit. Notice the perforated grill hovering directly above the critical zone. It blows purified air straight down over the operating table in a smooth, uniform stream. This constant downward flow creates an invisible pressurized shield. It actively pushes stray contaminants to the edges of the room, safely away from the patient. Even with perfectly filtered air, the physical terrain of the room presents a final vulnerability. Standard 90-degree corners are notorious traps for dirt and are completely impossible to mop clean. To fix this, builders install aluminum coving. By replacing sharp angles with a smooth, curved transition between the walls and floors, cleaning crews can wipe down the entire room flawlessly. That same logic applies to the ground. This hyper-glossy surface is epoxy flooring. It is highly resistant to harsh medical chemicals and is poured completely joint-free, so bacteria have nowhere to take root. Overhead, cleanroom light fixtures are fully sealed and flush-mounted with the ceiling, ensuring no dust settles inside the housings. When tools or medicines move in or out, they go through this stainless steel passbox. It's essentially a secure mini airlock. Interlocked doors ensure only one side opens at a time, allowing material transfer without exposing the sterile interior to a dirty corridor. By eliminating sharp corners, sealing every light, and tightly controlling material flow, the physical terrain of the room itself actively fights contamination. When the flush outer shell is sealed, the AHU lungs are pumping, the HEPA filters are catching the microscopic threats, and the coved terrain is sterilized, you get a system operating in perfect, simultaneous harmony. These unified turnkey setups are strictly regulated, built to comply with uncompromising global standards like WHO, GMP, ISO, and NABH. Constructing them requires specialized architects, like AUM Industries, who manufacture and supply everything from the insulated panels to the custom ducting to guarantee total compliance across the board. In the realms of advanced surgery and pharmaceutical manufacturing, 99% cleanliness is unacceptable. True safety requires an engineered environment where absolute control is the only standard.